Welcome. I'm Liz Taylor, ocean explorer, naturalist, and entrepreneur.
And I'm Sylvia Earle. I'm an oceanographer, National Geographic explorer, founder of Mission Blue, and I am an ocean elder.
Yes,
Thank you, Ocean Elders, for sponsoring this program.
absolutely. And this is our show, Dive In, where we host informal and open conversations with the ocean community on topics of wonder and interest. You can put questions in the Q&A box, and we will get to as many of them as we can towards the end of the program. And we'll be adding some links as we go along for attendees to check out. And as we get started, reminding everyone that the world is
Blue. It's not purple, orange, whatever. The world
is
Definitely blue. Definitely blue.
And today we are so grateful to have oceanographer and author John Englander rejoining us. He visited us about 3 years ago, and now he's back to talk to us.
And explorer, don't forget.
Absolutely. and my dive instructor.
Absolutely. One of my prouder
When you were
notable.
I was tiny.
14 years old.
Yeah, he put me through those the old school NAUI training. It was intense and very worthwhile. Thank you so much.
Yeah, absolutely. My pleasure. Good memories.
Yeah. So I'm going to try to attempt to share my screen. Let's see if this works. Look at that.
Always an adventure.
It is.
Great.
So John, love your book that really set the stage for the topic today. And, you know, it's, if anything, more urgent than ever that people tune in and catch up with the message, the evidence that you share so effectively. High
Well,
Tide,
thanks.
Main Street.
I taught on Main Street, and then the following book, Moving to Higher Ground. I mean, we're seeing that in action right now.
Right now, yeah. Sooner than one would have imagined.
Absolutely. Thank you. It's always a good opportunity to talk with both of you.
So it's, the Moving to Higher Ground, it just seems like it's such a must read, not only for, city planners and civil engineers and so forth, but just, ordinary people, especially people living along the coast or anywhere along the water. It's just very eye-opening.
As a
Thanks, Liz.
student years ago, I learned about how geologically speaking, sea level has been higher and lower than it is now in the 21st century, but at a stately pace over long periods of time. What we're seeing now, owing to human actions, accelerating the pace. So in my lifetime, I've already witnessed geological change, but the pace is picking up.
Yeah, this is something we really didn't predict. When I got interested in this 50 years ago, literally, there was no threat of sea level rising noticeably this century. And of course, the alarm was rung, and we were warned 30 or 40 years ago, actually earlier by some scientists. And we just never imagined that we could melt the polar ice caps, Antarctica and the polar sea ice and the Greenland in particular, at a rate that would change sea level visibly in our lifetime.
Yeah, meaningful. Yeah. Even a small amount makes a big difference when powered by storms.
Absolutely. And so we need to begin to differentiate and use language that we can communicate well with. And one of the things is flooding has many different forms. Sea level rise can be thought of as flooding, but it's kind of different because it's the base level of the base ocean level globally averaged, and will change as the oceans warm and expand slightly. But the real change for global sea level is when the amount of ice on land is reduced or melted. And that primarily happens in Antarctica and Greenland. They hold 98%, actually some would say 99% of the ice in the world is on Greenland and Antarctica. And therefore, they really are the main event in terms of future sea level rise. And they're melting faster and faster. And now with our satellite technology for the last 30 years, we've really gotten some good precise measurements that are now comparable over 3 decades. But it's causing us to face a different world. I mean, the shoreline, the coastline, the sea level have always been reference points, and they're moving, and they're going to move. And it's actually we can no longer stop it. This graphic, reminds us of the shape of Florida today. 20,000 years ago, when sea level was 400 feet lower than present, Florida was twice the size.
Yeah, there's another whole Florida out there.
And it's cool when you can go out, diving on some of these sites and you can see that evidence, right? You can find some, old camps and artifacts and stuff that are now underwater.
In fact, where we first became acquainted out in the Bahamas, using a little sub, going down and seeing the old shorelines. That
Yes.
I almost couldn't believe my eyes.
Yeah. The beaches down 200 feet underwater now.
Yes.
Yeah.
Right. Ancient shorelines and now submerged. And that image on the far right is pretty sobering, because, well, we know that has happened geologic past, times you think thousands of years ago.
Tens of thousands, yeah.
Something I don't have to worry about it. My property in St. Petersburg or Miami, we're safe. West Palm Beach. Only in Orlando can you maybe take a deep breath. Oh, now I've got beachfront property.
Right. Yeah, no, when to realize that 120,000 years ago that Florida was half the size when sea level was some 25 feet higher, and that's going to happen again. Even though the prior case was natural, now it's being directed by humans, which we've gotten out of the natural warming and cooling cycle that we think of as the ice ages, and now we're in this super era that we're thinking of as global warming or climate change.
And
and the infrastructure that humans have built, with a population, when I arrived on the planet, there were only 2 billion. By 1980, 4 billion, now 8 billion, with the largest concentration, this great economic investment that is, look at New York City.
Yeah.
Los Angeles, the big cities tend to be right on the coast, not all of them, but the great majority.
Most of them. Most of them.
And the thing that people always kind of come along and they're like, well, so what? It floods once in a while, it retreats, but you think about really what's kind of in some of the water these days as well, because when this kind of happens, you get the infrastructure, especially underground infrastructure, the steel, the pipelines, tunnels, things like this. They tend to have accelerated corrosion when the tide is coming in and you're just getting more salt content in that water. And when flooding happens, it's so often contaminated with all kinds of stuff.
Yeah.
So it's
we're not very tidy creatures.
No, but I mean it can be anything from agriculture to pet waste to septic systems to chemicals in somebody's backyard shed that all gets
sewer system that back up.
It gets mixed into this flood water, and it's quite damaging to reefs and just other ecosystems, let alone our health.
Yeah, indeed. We're living in a new planet, as you said, and it's hard to get our minds around it because back 20, 30 years ago, we were all concerned about the oceans and concerned about saving them, as it were. The hope spots were a great example and a great concept. But now we're in this new era where we have to accept that we're not going to be able to save everything. And so even more important to have protected areas like the hope spots, which both of you worked on so much. But we've really, we're past the point of no return to some degree. And even if everybody was driving electric cars and bicycling to work and doing all the things we might wish them to do to slow the warming, now that we have 8 billion people, as you said, and headed to 10 billion, we have to begin thinking about this new planet that we live on, that we're going to live to our kids, children, and grandchildren, and for future generations. We need to adapt to a planet with a different shoreline, different sea level height, And our whole construct, our whole reference point system needs to be rethought. And it's vital. It's essential that we pass on as livable a planet as possible. Some of it is going to be very different than what we grew up with.
Yeah, I think that's absolutely the case. And, you know, think about just the impacts to human well-being, but also just to our biodiversity.
So this is kind of a steady as she goes estimate that by 2050, the overall level of the ocean will be about a foot higher than it is right now.
This is from the more recent NOAA report, the 2022 report. It's a good report, but actually in the last 3 or 4 years, the scientific evidence with the melting of Greenland and Antarctica particularly, and also the warming of the ocean, which expands the ocean, so it also adds to sea level rise. It's probably more like a foot or 2 by mid-century. And so those estimates, those projections are being moved upward as the warming world, and particularly the last 2 years, which we can talk about, have broken all records. If we looking back to 1940, the warming in 2023, and here we are in 2024, both have broken all records by a long shot, by I mean, a great measure. And as the scientific community tries to figure out what does this mean for the rate of melting ice at the poles and rising sea level and the shoreline going inland, we have to think bigger because it's happening faster and faster. The rate of sea level rise and the melting of the Arctic or the polar ice caps is increased by about 30% in about 30 years. And
so, John, imagine if we did not know this.
yeah.
I mean, that's the thing. I think that there's a lot of bad news, but the good news is we do have the capacity to measure, to analyze, crunch the numbers, and make projections that should guide our behavior. If
Absolutely.
we did not know, that would be scary.
Yeah.
But we do know. What's scary is people are slow to accept the reality.
I was amazed to hear the report. I guess it came from the Bahamas where they measured the surface temperature like a month or so ago, 80 degrees, but that 80-degree temperature extended down 600 feet.
Right.
And I was just like, hang on, where's the thermocline? You're always kind of warm at the surface, but to have that warm water penetrate that deep in the ocean.
Surface, yeah, the deeper you go, the cooler it
gets. But it was just kind of crazy. And just think about the amount of energy and expansion that's going on.
And the last summer was, the Florida Keys had temperatures over 100 degrees Fahrenheit.
Which is insane.
Yeah.
I mean,
yeah.
Oh, like, yeah, it's with our body temperature of 98.6, you can overheat
by swimming.
in the water when you're by water actually colder than warmer than your body temperature. It's like staying in a hot shower, hot bath.
Yeah, it's good to keep our sense of humor, and as the three of us are very good friends and colleagues here, and we need to keep things in perspective. But of course, just to point out to any listeners, this is not funny. This is of course extremely serious. I know I know we all agree on and can't overstate the seriousness of this, but we are in a different era, and it's not like everybody's going to die soon, but the planet's ecosystem is on red alert, and the alarm bells are sounding. And as you were just saying, Sylvia, we have the information now. We've got to think even more aggressively. We've got to do more hope spots. We've got to do more things to reduce the greenhouse gas effect that's trapping heat in the atmosphere, 93% of which goes into the oceans.
Mm-hmm.
And that's why the oceans are warming and changing ocean currents and changing the Gulf Stream and threatening to change global weather patterns.
And changing the chemistry as well with ocean acidification, the double whammy.
Yeah.
We call it the terrible twin. temperature and chemistry both.
Yeah, and of course, there's lots of different ways to measure temperature. This is showing us since 1980. The lines go up and down. This is global average temperature, yeah, the anomalies. But the trend is very clear. And in fact, it's irrefutable. Now, some people like to cherry pick and take a section of it and show that maybe it's not going up as much as the overall picture, but you get better perspective and get rid of any anomalies by looking at a bigger view, as here we've got 40 years.
Right. That was 1980. It was when I personally observed in the Bahamas a big dome-shaped coral head that had been just a go-to place. And it was snow white. It looked like a big snowball, 1980.
So sad.
Yep. Bob Wickland, our
Sure.
mutual friend, he was almost in tears when he saw that. Must have been at least a 500-year-old dome of coral, and he just watched it die.
Wow. Now look at this graph is interesting. It's a recent graph showing how 2024 temperatures to date, the North Atlantic sea surface temperature compared to the temperature going back to 62, I think it says, or no, 82.
82.
Sorry.
Yeah.
Yeah, 40 years. The blue lines can all be decoded as to which actual year they are, but the point is that they're similar but growing in warmth. But
Yep.
this year is off the charts. Look at the red line. It's not just near the top of the blue blob of 40 different years. It's way off the charts, and it'll probably start coming down by the fall because the La Nina event in the Pacific is finishing, and that's added to global warming and the effect on sea surface temperature. So it may come back down closer to the higher blue lines, but just on its face, this is scary. I mean, if indeed we are in a mode where the warming has kicked into a higher gear, which is
Yeah.
what this suggests.
Well, there are these feedback mechanisms. You've noted it in your visits to polar regions when the white surface retreats, darker surfaces emerge, and the dark surfaces absorb more heat. The lighter ones reflect the heat away, and the more that it melts, the
Faster.
faster the
Yeah,
absorption. More dark water. Even innocent things are seemingly innocent, like icebreakers. They're useful. We need them, right? But every time an icebreaker cuts through solid ice, it makes a lot of little tiny ice cubes, which melt faster,
Well, yeah.
and they leave a big trail of dark water behind.
You kind of think of, you have a block of ice versus a cup of crushed ice.
Yeah.
Which one melts faster?
Right.
I mean,
Yeah, no, it's one of those feedback loops as well, as you say, that the warmer the world gets, the more we go from white to dark blue. It absorbs more heat, which melts more ice. It is a vicious cycle.
Yeah. And of course, the more that we pave over, wilderness areas and so forth, you get
with dark
pavements.
surfaces
Yeah.
that absorb the heat and take away the trees. Oh my goodness, that absorb the carbon dioxide.
Yeah.
And similar disruptions to the carbon cycle in the ocean by taking industrial scale extraction of carbon called fish and shrimp and squid and krill and all those things people take as a given in the 21st century, but they are not only fast disappearing, but their loss has climate consequences.
Sure. No, it's a new world. I think trying to get back to the old one is actually not a good idea. We need to tackle certain things, specific projects, but we also need to realize that we can't go back to the world as it was 40 years ago either. And so we've got to do both. We've got to educate people. We've got to protect some things where we can at the right scale. It's kind of like triage, and as they say in the battlefield, save what you can, identify things which will be fine on their own, but recognize that not everything is going to survive, and we need to put our resources into places where we can make the big difference. And that would include, to me, hope spots and various efforts to get plastics out of the ocean and some other terrible things. But from the basics of the heat, melting the ice, raising sea level as Greenland and Antarctica melt, following what happened 120,000 years ago by nature. But for most people, Antarctica and Greenland are out of sight, out of mind. And as this slide reminds us, I mean, that's where the ice is. It's 99% in Antarctica and Greenland. I'll be back there in Greenland in 2 weeks with kind of our annual Rising Seas Institute fact-finding expedition. And although this trip is full, anybody who's interested can go to our website, risingseasinstitute.org, and find out about future expeditions to kind of see this firsthand. It's been great to take journalists and opinion makers and even some members of Congress and military leaders there to see the scale of Greenland and the scale of the glaciers and the icebergs, which are just beyond comprehension. We don't need everybody to go there, but we certainly need a few people to communicate what's happening.
That cross-section of people, including the military, is so important. This is a security issue. It's financial, it's ecological, but it's planetary security. It's human livelihoods and lives, and the rest of life on Earth as well. And of course, it's all tied together.
This is I think a great image because, most people think, oh, Greenland, it's a little island. They have no idea the size.
Kind of a biggish island.
Yeah, it's kind of biggish,
Yeah.
exactly.
Equal to the eastern United States, covered by a mile or more of ice. And it's just melting faster and faster. It's breaking all records.
Yeah, and to your point, this is where it really gets to the truth of the matter is that this is this ice that's up on the land. It's not in the ocean yet.
Right.
But if that melts faster and faster, it's the cup overflows. It just starts covering the land. It's got to go somewhere.
Yes, and for those that aren't familiar, so Antarctica has been melting slower than Greenland. The Arctic has been receiving more of the excess heat because of ocean currents and the fact that it is frozen water as opposed to land. The heat content is higher in the Arctic, and Antarctica is so much bigger. It tends to keep itself cold, if you will, and act like a deep freeze. But things are changing, and Antarctica is now melting faster and faster. Greenland's melting much faster. If Greenland were to melt entirely, global sea level would be about 25 feet higher. That's not going to happen for hundreds of years, perhaps a few thousand years. But Antarctica's 7 times that amount of ice. And the problem is that, as you may have seen in headlines and articles, even in the last couple of weeks, there's more and more evidence that Antarctica is melting or warming faster than all of the models. And people think that scientists may be exaggerating this problem. The truth is we keep proving is that the scientific projections are too conservative, that the actual warming and melting is exceeding the projections. We are now looking at 2 or 3 meters of sea level rise this century. That's effectively up to 10 feet. Can you imagine a global sea level rise of 10 feet higher? Whether it happens by the year 2100 or the year 2124, it's not that. The point is to think of scale. We in our understanding of the planet's history and during our civilization, we've never seen sea level higher than present. We've seen temporary flooding. We've never seen sea level higher than present. It's going to happen because at this temperature, the ice on Greenland and Antarctica have to melt to a considerable degree.
Yeah, and it's interesting, some years ago we built a very, I'll say very bespoke ROV. Its whole job was to go down through boreholes in the ice and to kind of check out what was going on underneath. And one of the things is that the scientists were kind of measuring salinity and just kind of looking to see what was going on the land. And what they're beginning to see is that it was also melting like from below in addition to from above. So you had this, as creeks and other lakes frozen under the ice began to get warmer, they're moving, right? They're going downhill and they're starting to flood out underneath the ice. And so that just that movement of water can help thin it. And
Sure.
it was so it's kind of more alarming because you have sort of warmer water as it is happening. And then that just that natural movement of water coming down slope to thin it more. So there's some thought that that's what kind of helps to create these bigger sections, those kind of snapping off unexpectedly.
Yeah. So here we see the rise in sea level since 1980, I guess. No, I'm sorry, 1850. This is the long slide, right?
Yeah.
Okay. And the general trend has been upward. Little warbles in the line, and that's perhaps within the accuracy of the various techniques since 1850 to the present. But in the upper right is the little red line, which is when we've had satellite data. And if you just look carefully, you can see that the angle of the slope of the blue, the water level, sea level, is inching higher. It's angling higher and higher. And I think if we go to the next slide, Liz, just yes, that shows since we had the satellite measurement starting in 1992, the TOPEX was the first satellite that could measure sea level globally on a repeating basis every day. And if we advance to the next slide, we'll see that at the beginning of this chart, which with the TOPEX data, which is much more precise than the old systems for measuring global sea level, that it went from 1.5 meters per year, about a 20th of an inch, and doubled by the next decade. And then in this decade, most recent, it's about 5 millimeters a year. It's 50% again. This isn't quite exponential growth, but it's getting close to it. It's the early, I would say it's the early stage of exponential growth. And as we learned from the pandemic a few years ago, exponential growth, and when there can be abrupt changes in rate without warning or without that are somewhat unpredictable, that's what we got to watch out for, because that's when the growth in numbers will really bite us in the butt, if you will. Here, if we lay on since the last ice age peak 20,000 years ago, which we referenced earlier, but sea level again has risen almost 400 feet. Now, what's interesting here is it changed, the rate of sea level rise increased quickly. You can see how the slope of that blue line, the rate of sea level, is going higher and higher until about 6,000 years ago when it leveled off. And people who were alive at one of those blue arrows, if you will, if they look backward to say what's happened, they could not predict the future because there was a rate change in their future. There was abrupt change in the rate of sea level rise. This has happened historically. We humans came along and got civilized about 6,000 years ago, 6 or 8,000 years, maybe 10,000 years ago. But the point is that for almost all of human civilization, sea level has been pretty stable to the point where it was a reference point. We measured distances above or below sea level, right? And sea level determined the shoreline. If sea level goes higher or lower, the shoreline changes, as we saw with that Florida image. But that's a global change. And we tend to disbelieve things unless we can see them and we've had experience with them. And the problem is we've never seen permanent sea level higher than present. We've seen temporary flooding from storms. We've seen it at peak tides, and various temporary kinds of flooding that'll happen based upon weather events typically, as well as, of course, the changing tide cycle. But we've never seen sea level be higher than present for all of human civilization. And that's why we really have to sound the alarm bell, and that's what I try and do in my book. We're going to need to begin to move to higher ground. Back to I think your earlier question, Liz. Are we going to move cities? Well, people will move eventually on their own if they understand the future, if they get educated, and if we stop thinking the government can protect us from this. we're past that point at this point. This shows 400,000 years of sea level in blue, up and down, 400 feet, left to right. And then in red is global average temperature, basically depicting the ice age cycles. There's 4 ice age cycles shown in that red line from 9 degrees Fahrenheit and 5 degrees Celsius is the top to bottom of the red line, going up and down over about every 100,000 year. Every 100,000 years, we have this warming and cooling cycle we think of as the ice ages. It's been happening for 2.5 million years, long before humans were around. And that's driven by an orbital change. I won't get into here, but again, for anybody interested, my book or my blog post. But then
we can't do anything about that, but there are things we can do that can make a difference.
Absolutely, because the green line is carbon dioxide. That's the greenhouse gas. And if we see that carbon dioxide has gone up and down with temperature for 400,000 years here, and actually it's been 2 million years, but on this graph, it's 400,000 years. And the problem is that green line that's shooting up like a rocket in the upper right, in that dotted circle with the yellow arrow pointing to it. The level of carbon dioxide has gone up to 425 at the moment. And historically, going back millions of years, it varied from about 140 to about 280. And now it's at 425, 50% higher. And that's the problem. That's what's trapping the heat in the atmosphere.
So about 3 million years ago. Wow.
3 million years ago, the continents looked different. The shorelines were different, and because sea level was different. And now we
go, right?
downtown Miami, Biscayne Boulevard. But all over the world, this could be Seattle, this could be Copenhagen, this could be any coastal city, as you said, Liz. I mean, most of the population centers are on coastlines, from Mumbai and Jakarta to, we think of Miami or Los Angeles or New York or Boston or Seattle or Vancouver. We could go around the world. Tens of thousands of coastal cities were built assuming that sea level was stable. Assuming that we'd have temporary flooding, but that sea level was stable. Well, now we have this new reality that sea level is going to be 5 or 10 feet higher and then continue to rise because of the heat that's stored in the ocean. And we're seeing it at these king tide events, probably spring tides or perigean high tides, but what we call spring tides. And the spring tides are getting higher, not because the tides are the moon's any bigger pulling on the earth or the ocean, but it's
Another factor, John, is the saltwater intrusion in freshwater systems that, again, because of the concentration of people on the coast, freshwater is critical for human
existence.
And the infrastructure is the springs that even in Florida, you can see it where they're just being overwhelmed. The saltwater inexorably is moving further inland, even though it's not as obvious right on the shore. The subsurface, I mean, Florida is like a big limestone sponge, and doesn't have to be a very large increase because it's just, as you point out, it's inexorable. It just you can't stop it. Well, it's true in Texas. It's true everywhere along the coast. You get just this underground action.
And I think it's important to educate people that, again, this happened by nature. So I mean, there's certain things that we know is only done by humans, like plastics in the ocean, right? That's definitely a human construct, right? That could not have happened without humans making plastic. But sea level being higher than present, as we showed earlier, has happened before as part of the ice age cycles. Now we've broken out of the ice age cycles. We're warming when we should be cooling. We should be heading to the next ice age 80,000 years from now. But the planet's too warm for that to possibly happen. And as the ice on Greenland and Antarctica melts more and more, we're going to get to these record levels record water levels that we've never seen before, but the planet has seen them the last time again. And so I think that's all part of the opportunity to educate people and say, there was sea level, going up and down before, but now we've taken charge of the throttle or the accelerator, and we have to realize that we have to slow it, we have to adapt to it, and we have to recognize that there are some things we're not going to get back to the world we knew 50 years ago.
Yeah, it's like Sylvia, people always ask Sylvia, where's your favorite place to go diving? And she'll say anywhere 50 years ago. But it's because the change has been so dramatic from, the normal things that go on, but just these abnormalities of accelerated change.
There's one thing that climate scientists, including Johan Rockström, are seriously addressing, and that is Earth is not just rocks and water. It's alive. It's a living system. And we kind of get it with the land. You see these areas that are targeted in this map. One of the prescriptions for trying to stabilize the runaway changes that we are causing and experiencing is, let's plant 1 trillion trees to capture more carbon dioxide, to, of course, generate oxygen, but to put back much, or at least some, of what has been deforested. Much of this has happened in the last century, where only about 5% of the old growth forests, that is, those forests that have been around for 1,000 or many thousands of years without significant intrusion or change by humans. And we're really good at consuming nature. What we have not been as mindful about until just recently, and it is happening, it is changing, the recognition that we're clear cutting the ocean of life. It's carbon. The calculation on the carbon value of whales, for example, just whales, even with their current depressed level, on the order, if you want to put a dollar sign on it, is more than $1 trillion worth of carbon swimming around in the skins of whales, live whales.
Wow.
What's the value?
Nothing.
You can pounds of meat, barrels of oil, but look,
Wow.
Sorry.
It has to work for tuna, for shrimp, for all living things. We are carbon-based units too. We have a carbon footprint. But when you think taking all that life out of the ocean, about half of what was there when I began to explore using scuba in the 1950s, about half of the life that was there, carbon-based units, has been taken out of the ocean. We've lost half the coral reefs, half of the kelp forests, about half of the seagrass meadows. They're simply gone, displaced or consumed. That has climate consequences. It's the carbon cycle, stupid, I want to say. But we have a different mindset about the land and the ocean. We so value the dollar sign on monetizing life in the sea, whether it's whales or krill or shrimp cocktails and tuna salads and sushi and all those yum things. But there's a real cost that we have not accounted for, and the worst is the billions of dollars of subsidies to really accelerate the defaunation, if you call it that, the de-wilding of the ocean. And to know that, and you just, I mean, you can't unknow it.
Yeah.
But most people don't see it. They don't.
No.
The climate scientists generally have looked at the physical calculations and focused on the land, and they have not really taken the ocean, not just the absorption of heat and the distribution with currents and all of that. It's the carbon cycle. It's the living systems that even coloring the water with plankton blooms has an influence on how much heat is absorbed or how much is reflected. They're just have to think like a living planet, not just a physical phenomenon.
All right, let's see here.
There you go. Watch out.
Can you hear this video or?
Yeah, we can.
Great. Yeah, this is Rockstrom. It's a good little video. It allows us to make a couple of points.
Carbon dioxide into the atmosphere.
But he gets to the planetary tipping points as his institute has defined them. And this is just, of course, a quick video showing disasters all over the world.
Yeah.
In a moment, he's going to
Oops, go back.
Here.
Sorry.
Sorry.
I do. I thought it
Can
was,
we?
I don't know if we can go back to it or not. Let's try. Nope. It's not going to let us
No.
go back to it. Okay. Weird.
All right, sorry. But well, actually, he says there's 16 planetary.
Ah, there we go. Need to reset.
Should we just let it go till he speaks or?
Yeah.
Okay. Because he's going to connect Greenland and Antarctica and the ocean currents in a moment, which is quite relevant. And this is showing the effect, of course. Again, we've just seen this, but then when he takes the stage, and he's the head of the Potsdam Institute, one of the better climate institutes in the world, it's in Germany, and talks about the tipping points.
Dear colleagues, friends, we're taking colossal risks with the future of civilization on Earth. We're degrading life support system that we all depend on. We're actually pushing the entire Earth system to a point of destabilization, pushing Earth outside of the state that has supported civilization since we left the last ice age 10,000 years ago. This requires a transformation to safe and just Earth system boundaries for the whole world economy. The question is, why? These are the 16 tipping elements, the large biophysical systems that we have scientific evidence that it regulates the state of the entire climate system on Earth. 9 of these 16 are showing signs of instability. Push them too far, and they will shift over from supporting humanity to starting to undermine humanity. 4 of these are showing scientific evidence of now being at risk already at 1.5 degrees Celsius. We're approaching this point very rapidly. 2 of them, the Greenland ice sheet and the West Antarctic ice sheet, together represent 10 meters sea level rise. This shows scientifically that 1.5 degrees Celsius is a physical limit. It is not a political target. But what I say next will be the most alarming thing. We have more and more scientific evidence of connectivity between these tipping elements, cascade risk of dominoes. Let me give you one example. Here's the one that is most researched. Greenland ice sheet, accelerated melting, warming 4 times faster than the planet as a whole, releasing cold, fresh water, slowing down the overturning of heat in the North Atlantic, pushing the whole monsoon system down further south, causing droughts and forest fires over the Amazon rainforest, one more tipping element system, locking warm surface water in the Southern Ocean, accelerating the melting of the West Antarctic ice sheet. The North Pole is connected to the South Pole in regulating the stability of the entire Earth system.
Yeah.
There you go.
Bam. Absolutely.
Yeah, he's excellent.
Imagine if we did not know.
Right.
We would just be complacent, continue merrily along until.
What's this in my living room? It looks wet.
Hmm?
What's in the living room? It looks
Yeah.
wet.
Yeah, no, we all need a wake-up call. I mean, we're of the same team, obviously working as hard as we can, I know, for all of us. We need to find new ways to tell the story, and we unfortunately now have reached a point where we have to do this effective triage. We have to decide there are some things we can't save, and it's important that we pick the things we can that have priority, and then educate people about what's at stake here. This isn't a political game, and it's not a matter of just how much money or there's lots of ways to look at this, but the planet's changing, and I use sea level rise because it does get people's attention that their valuable land, their dirt, as you like to call it, Sylvia, is being clawed away by the ocean. I think makes a particular point that we think real estate is so valuable, but the sea is in charge, and the sea is the height of the ocean and the shoreline is a function of how warm the planet is. And the differential or the variable is the amount of ice on land. And it's 99% in Greenland and Antarctica. And the facts are really clear now, much clearer than when I wrote my first book in 2012. And Moving to Higher Ground, the book a couple of years ago, was much clearer. But since then, the facts are even stronger. The scientific community is clear that the efforts to slow the warming are not working. We keep reducing them or claiming a victory with a really small amount of success. We have to start thinking bigger.
Yeah.
So ironic, isn't it, John, that we use the term about along the shoreline, the term reclamation. You take the ocean floor and you make dry land out of it. You put parking lots and condos in San Francisco. About a third of the city is actually on land that was, quote, reclaimed from the ocean. Well, now the ocean is reclaiming the reclaimed. Right. It's never ours in the first place. It's always something that an odd term. But the other thing is
go ahead.
We can take action like planting 1 trillion trees and not taking 1 trillion krill out of Antarctica. The carbon cycle, the powering, and I mentioned that a calculation on whales, they're worth, by Ralph Chalmers, who's an economist who did crunch the numbers, also noted that it's not just the carbon in the animals, it's the fertilizer that they produce that powers the phytoplankton that captures the carbon and generates oxygen and drives the great ocean food webs. It's not just whales and plankton and krill, it's every living thing is connected. And for us to think that it is smart to take ocean wildlife by the ton to reduce what was there by half since the 1950s, we can take action. With every bite you take, you're taking a bite out of the ocean, if you will, with climate consequences. And I know it's hard when you have habits and customs and livelihoods that are based on old ways of thinking around a planet that no longer exists. But the laws do exist that reinforce those old habits. But once you know, you can make personal choices. You don't have to wait for laws to catch up.
It's absolutely true, because I mean, as you often say, no one can do everything, but everyone can do something.
Right.
And there are others, there's things that people can take a bit of charge in their daily lives that can make small differences, but they stack up.
Times 8 billion.
Yeah.
Every bite counts.
Every bite counts, every stitch of lawn that gets turned back into biodiversity spaces. It all kind of helps. Depaving, and walking more. Get out of the cars. So, well, we have a couple of questions in the queue.
Great.
We might get a few more, but we'll grab these.
I have some questions.
You always have
go ahead.
questions, I know. So Terry's asking, what will happen if the AMOC stops or slows down further?
Sure. Well, the Atlantic Meridional Overturning Current, as it's nicknamed, the AMOC, is that conveyor belt that goes up the Atlantic, and with the Gulf Stream's essentially part of it as it goes past Florida. and it gets up to Greenland. And because of the melting of the Greenland ice sheet, again, the fresh water entering the ocean up there, it's reducing the driving force on that conveyor belt that normally was denser, cold seawater in the North Atlantic that would, as the warm water got up there, it got affected by the denser cold water and was powering that conveyor belt in the oceans. By the way, it's estimated it takes 700 years for water to make the circuit in the oceans around the planet. Just think of that as a challenging our time frame. We think a year is a long time.
Yeah.
Wally Broker, one of the outstanding scientists, did that calculation that takes about 700 years for full mixing of the planetary ocean cycle. I think still the estimate. But the conveyor belt, back to the question, it is slowing down. The Gulf Stream is slowing down. The conveyor belt, the AMOC is slowing down. It's hard to predict exactly how it will happen. And it's been alleged that if it gets much slower, and certainly if it shuts down, that Europe would be greatly affected because it's carrying that warm ocean water up to the North Atlantic and coming over toward Great Britain or Europe. And we'll see. But the measurements are getting better about the Atlantic current. And it could have devastating effects as we put more heat in the ocean and melt Greenland, and that fresh water, it's that fresh water entering the North Atlantic off of Greenland that's much lighter than the dense seawater. And that's what's slowing the current in terms of the simple physics, that as Greenland melts faster, it's replacing the cold, dense seawater with light, fresh water and much less weight. And that's why the AMOC is slowing down, we believe. By the way, there was that great, or not, I shouldn't say that great, there was a movie 20 years ago that I'm sure you both remember, The Day After Tomorrow.
Oh,
And
yeah.
I watched it recently because I thought that was terrible science. And the idea that in 3 days, the Gulf Stream would shut down and New York would be under 20 feet of ice, and this whole silly story, if you will. But I went back and watched it recently, and I was stunned that the science was better than I thought, because what had confused me was the simplicity that that in a warming world New York could be frozen. It would seem contradictory, but there actually was some script in that film that talked about it being a collapse of the thermohaline boundaries. And basically what it's saying is that as we melt Greenland and we get fresh water, we're changing the salt boundary, the temperature and salt, which is the key driving force of the ocean currents, temperature and salinity. And of course, the gravitational rotation, the Coriolis effect. I mean, there's lots of different effects, but temperature and salinity are two dominant drivers of ocean currents. Okay. And that film 20 some years ago was attributed this bizarre weather event and the melting, but the freezing of New York as part of the whole collapse of this thermohaline circulation. So kudos to them. I used to kind of besmirch and make fun of that movie, but maybe they were 20 years ahead of their time and I hadn't
Never know.
remembered.
You see
Well,
these things.
They say that the Northern Europeans from Norway and Sweden to the UK and that whole area should be thanking the Gulf Stream every day for the relatively mild climate that they have based on their latitude.
Yes.
Without
Yes.
the warming effect, it'd be pretty chilly. But
Absolutely.
take away the Gulf Stream and its warming effect, slow down, or just disrupt the distribution of the way the planet is currently kept at whatever it is. We're adapted to the present
Exactly.
range and alter it, and it has far-reaching consequences.
And there's some new research which indicates that it really is happening faster than even those of us who have been concerned expected. There was a paper just a couple of weeks ago, Stefan Rahmstorff, one of the better oceanographers out of Germany, again, says now he has like a 35% level of concern that we could see a very quick collapse of the AMOC because of what's happening. The recent information is even more alarming than it was a year ago.
Wow.
Yeah.
All right, next question.
Okay.
Jenny says, as you said, sea level will continuously rise. I'm understanding correctly that this may not always be an even, consistent process. As such, we would also need to be prepared for sudden jumps triggered by bigger events and cannot expect a slow, steady rise, even rates from year to year.
Okay, so rates of sea level, the rate will change because the rate of the melting of Greenland and Antarctica will change. And it's largely unpredictable, just like for the same reason that a California earthquake or a mudslide on the coast highway or an avalanche in the Alps, none of those things are predictable in terms of when. Those are geophysical events, and we can model them, but we can't predict them. And it's a good metaphor. And the collapse of those two ice sheets that are a couple miles thick and of such huge size do not predict well. The rates are varying and they seem to be accelerating. It's not a linear curve. We mislead people when we show different linear curves of sea level rise. It hasn't risen in a smooth curve before, as we showed in some of those slides. In terms of the rate of how fast it could happen, it's hard to say, but all of the scientific evidence says we've been underestimating the potential.
There's the other thing that the first time that I saw the planetary boundaries concept that Johan Rockström constructed some years ago, and his colleagues had an element that said surprise. Surprise. What it means, I guess, is that we don't know what we don't know. We need to calculate for that element of how much we still have to learn about, especially the ocean.
Yeah.
But and the interconnections that we haven't yet understood, the feedback mechanisms, or how the living systems and the physical chemical systems all interact. So maybe we should be applauding the arrival of AI that helps us maybe crunch the numbers even more effectively, but still we need to, we've only seen maybe 10% of the ocean, as you know, John. We're just skimming around at the surface. We are trying to probe with various instruments the three-dimensional nature of the ocean. But again, what I think gives me some cause for optimism, Rockström says the big X factor is the ocean. That we hope that what we don't know is going to work in our favor. and
yes,
but it's still the principal governance of Earth's climate and weather. The habitability of Earth is governed by the existence of the living ocean.
Yes, and the temperature range.
Yep. There would be no life without not just the water, but the water plus life makes Earth habitable. And there's plenty of water elsewhere in the universe, but this is the only one that has that magical combination of water plus not just microbes, but microbes and 4.5 billion years of working, interacting. And here we are with a planet that's suitable for us. It's taken a very short time for us to kind of disrupt that big blue engine that keeps us alive. But it's always the but.
It's always the but.
Now we know.
Okay, we're almost the top of the hour, but we have 2 questions left.
Oh my
So,
gosh.
John, if you're willing, can we do them both? Okay.
Sure.
We'll take them off. We'll take the last one first. Can you address the impacts of deep sea mining on ocean and marine life? And what does it mean for sea level rise? What do you think?
I'd have to give a little thought in terms of what ocean mining means for sea level rise. I think not too much. I wouldn't say that's a major concern. Deep sea mining has certainly biological concerns and disruption to the seabed. But again, it's global temperature. It's global temperature that's melting the ice sheets and taking manganese nodules or whatever else it is, we're taking off the seafloor. Usually has collateral damage is the problem. We're wiping out the deeper reefs or fisheries or seabeds or seagrass or whatever. It's not the taking of the manganese or whatever the nodules are, to my knowledge. Maybe Sylvia knows better.
I think some of the concerns have been raised about, again, it's the carbon cycle.
Yeah.
The vast quantities of carbon are in the seabed. And you're right, the actual contribution of taking, if you could just magically lift them out, and lose a lot of species, it disrupts stability. But there's more than that. It's not just, there's no nice way to take manganese nodules.
And it's the disruption of the entire water column and
Yeah,
all the
that's the
plankton and
point.
everything
Right.
else that really is, I think, where it kind of feeds into everything else we've been talking about. It's like the surprise tipping point,
Yeah.
Yes.
We'd be better. The precautionary principle is, I think,
Yeah.
really, really needed there.
There are climate consequences.
Yeah. Okay.
Yes.
One last question.
Yep, let's go.
Okay, with the population that's ever increasing, it will render large parts of the low-lying coastal areas uninhabitable with sea level rise and desert spreading. Are there realistic solutions for sustainable urban living? Considering the available space?
Underwater?
Now stop.
I mean, we'll do more things on floats. There were some slides earlier that showed, some designs for floating cities.
Yep.
We're not gonna house everybody on floating cities. That's totally unrealistic, but there'll be some. We'll move to higher ground again, just the logical thing. If you thought that in the next 10 years, sea level could rise 10 feet, I mean, if that was a real possibility, and I don't think it is, the coastal real estate values would go down tomorrow morning. I mean, that, nobody would want, but it's the uncertainty of knowing how long it will take to happen that fools us into thinking, well, we can leave that for the next generation.
Yeah.
So, but clearly in a world with, the 8 billion people going to 10 billion people, and we're having developed coastal lands from all over the world, 140 nations have an ocean boundary. Okay. And in those 140 nations, so it's the 2/3 of the nations in the world and all the big nations, well, yeah, except for maybe Germany or something like that, that we're going to have to consider that with the shoreline moving inland and unpredictably, that we're going to have to at some point try and get ahead of the curve instead of just catching up with another inch of sea level rise and another inch and another inch. Sooner or later, we're going to realize that we have to plan for the future. And we're going to have to find a way to build 10 feet above sea level while we're dealing with all the power, the energy issues and carbon dioxide in the atmosphere and all these other things. We're going to have to do these three things at once. We're going to have to take the ocean conservation issues. We're going to have to solve our energy problem and make energy without warming the planet. And we're going to have to adapt to the world that we can just begin to see over the horizon. It's inevitable. We may not want it to happen, but it's it's something that we have to take seriously. And that's why I try and explain this, as you know, in my books, to really make the science very easy to understand by using plain language, no jargon, no technical science stuff, to use explanations about the melting ice and the rising oceans in a way that anybody can understand it. Because I still think that's our first need, is to educate people. And I know both of you are well, that's why we're doing this today, is to educate people
Yeah.
that sometimes scientists like to make things technical and complex. And when talking amongst themselves, that's fine. That's the advancement of science. But when we talk to the public, we really should make it easy to understand and use plain language, slow the warming, reduce the flooding, not mitigation and words that but the average person doesn't absorb very quickly.
Yeah. I think we should all just, especially because we have the debates happening later tonight. I think
Oh, my
Yes.
I think we should all go out and get a copy of your book and give it to your favorite politician. And then we all need to vote wisely.
Should be bedtime stories. for
Bedtime
kids.
stories.
Yeah.
Thank you for that thought and that connection. And
Yeah.
it's my pleasure. And I appreciate you're making people aware of it. So moving to higher ground, it's available as an audiobook. It's available as a Kindle or an ebook and hard and soft cover. And I've had great response. In fact, the sales are actually picking up now. And again, it's probably this extra flooding that's happening.
Right?
But I'm getting more interest in not only the book, but speaking engagements and helping different groups think about what does this mean for them.
Yep. Let's all work together on it. Keep
Yes.
on working.
Yep.
All right. Well, we're past the top of the hour, so we've got to take off for now. But before we go, we want to say thank you again, John, and to Ocean Elders and everyone out in the dive-in community that continually shows up and participates in these conversations. Water connects us all, even when it's rising. We're so grateful to you. We will be back in September, taking
Yes.
the summer off, and that means everybody should be getting outside,
And read this book.
read this book, stay
Yes.
curious,
Thank you.
and take
Thank
care of
you.
the ocean as if your life depends on it,
That's it.
because
It does.
It does. It does. Thank you both for everything you do. You know, we've been
Thank you, John.
we've been at this together for 50 years. It's hard to
I
believe.
know.
Oh,
Yeah. But we'll keep at it.
All right. Bye
Thanks
for
to
now.
both of you, and thanks to Gigi, and thanks to Ocean Elders.
have a great summer.
Yep.
Thank you.
See you in the
You too.
fall. Thank
Love you.
you.
Bye.
Bye.